dumb question, isn't it? We all know the universe began with the Big Bang. But might I ask, what came before the Big Bang? General relativity says the Big Bang was preceded by a gravitational singularity, referred to as the initial singularity. Now the problem with singularities is they pose our laws of science. At a singularity, there's no predicting the past or the future. You're pretty much stumped. Or so we thought, until Stephen Hawking and James Hartle came up with the no-boundary proposal that aims to understand that initial singularity better. This is the no-boundary proposal in 3 minutes. Stephen Hawking's work with the singularity theorems proved that at a singularity, the gravitational field becomes so strong that quantum gravitational effects become important. So goodbye classical theory, the science of the ginormous, and hello quantum theory, the science of the very tiny. You will remember from Schrodinger's Cat in the Hat. Box. Unfortunately, we do not have a consistent theory that combines both classical and quantum theory. But we do know that it should include Richard Feynman's sum over histories, which is a very cool concept, but I will cut to the chase. When you actually try to do the math involved, you find it doesn't work really well. Hawking and Hartle's reaction use imaginary time instead. It is a mathematical device used to calculate answers about real time. What is really cool about imaginary time is that it is indistinguishable from the dimensions of space, giving us what is called Euclidean spacetime. Euclidean spacetime is not quite different from Euclidean space from geometry class. It just has 2 more dimensions. Okay, so now we have a universe that is in a quantum state in imaginary time, right? In this state, the universe could be comparable to the surface of the Earth, which has no boundary and no edge. Likewise, spacetime has no boundary or no edge at a singularity where the laws of physics would break down. Therefore, there would be no need to calculate the characteristics of the universe at that boundary. In this state, the universe would have no beginning and no end. It would just be. And all of that gives rise to the Shuttlecock Model of the universe. It begins with all the dimensions behaving as spatial dimensions. This Euclidean region eventually changes. The spatial dimensions remain a circle, but the time dimension opens up. It separates from the dimensions of space. This model describes the universe whose spatial dimension grows and grows and grows, and you get the picture. And that is the end of that. Well, not really. We still don't have a theory that combines both classical theory and quantum theory. We will know the answer one day. But till then, let there be no boundary to human endeavor.